Heat pumps. There is quite a trend in installing them as a solution for home heating, and today I'm going to share my experience with a heat pump, a Hitachi Yutaki S Combi heat pump, after a complete cold season. I have bought the heat pump for my own house, making my own independent decision, so you will hear my genuine experience and technology explanation from the point of view of someone who has made an investment in this technology and after a complete cold season can share actual impressions, numbers and facts on it. So let me introduce you the exact type and model of the heat pump I have here. It's an air-to-water heat pump, which means it captures heat difference from air and transfers it into water in the heating system, and that water circulates in the house and heats the house. But it ensures not only the heating but also the domestic hot water, or DHW as it is often called. So hot water for all the bathrooms and kitchen is also provided by the very same heat pump. And here I come to the exact model. It is a Hitachi Yutaki S Combi heat pump, and you can see the exact model codes on the screen for indoor and outdoor unit. Well, the Combi part in the model name means that there is a boiler integrated inside this unit that stores the domestic hot water. Otherwise, if you want your hot water to be heated by your heat pump and you don't have an integrated boiler, you would need an additional unit with additional space and investment that also requires to be configured to work properly with your heat pump. The boiler stores 220 liters or 58 gallons of hot water, and in my case it provides hot water to 3 bathrooms and a kitchen. Is this volume of water enough? Yes, you can have a full bath of hot water without it suddenly ending. And for shower part, 2 people can take a shower in 2 separate bathrooms in parallel without any problems, and probably even 2 after them. So if you don't sing a whole long opera while taking your shower, it is always enough for everybody in your home. It is a 16 kilowatt heat pump, a powerful one with double size compressor, which is suitable for larger homes. In this case, we are speaking of about 270 square meters or 2,900 square feet on 3 floors, with 3 bathrooms to provide hot water to. But of course there are less powerful versions and more powerful ones, so everything can be related almost proportionally to the area of your home. For example, this is the most powerful heat pump in the Hitachi Yutaki S Combi range. The least powerful is 4.3 kilowatts, and then they have 6, 8, 11 and 14. They also have 2 more powerful models, 20 and 24 kilowatts, but those do only come without the integrated boiler, so they are not from the Combi range. So such a Combi system is convenient if you want the hot water for your home to be provided by the heat pump. Otherwise, you can have a normal unit and choose if you need an additional boiler to work with your heat pump, or you just don't need that function at all because it's provided by any other system in your house and you can focus on the heating system only with the heat pump. Well, before telling why I chose a heat pump, how to calculate the needed power, and of course speaking more about my experience, let us do a short dive into the technology, explain it in simple terms, see why any of us would choose a heat pump, and why it is said to be much more energy efficient and environmentally friendly. Heat pump is basically a device that can capture heat from one medium and transfer it to another one. The whole heat pump technology is built around profiting from the temperature difference of the 2 mediums. So we definitely need one medium to extract the heat from, and that can be air like here, or that can be the underground natural heat of the soil for geothermal heat pumps. You see, physics teaches us that heat dissipates, so it migrates to the colder medium. Okay, you would say, but in winter it's cold outside and it's warmer inside. So how on earth can you capture heat from a -5 degrees Celsius or 23 Fahrenheit and consider the inside medium a colder one? Well, as Archimedes said, give me a lever long enough and a fulcrum on which to place it and I shall move the world. So it's all about having the right lever and fulcrum, the refrigerator liquid and the pressure formed by the compressors. So the key is to have a circuit with refrigerant liquid that is colder than the heat source, outside air in this case, even at low temperatures. The outdoor unit blows air into a heat exchanger, where refrigerant is beginning to evaporate inside the circuit and turns into gas. That gas is further pressurized by a compressor because at higher pressure, gas becomes hotter. Gas that has been additionally heated by pressure passes then to the internal unit, where it arrives in a heat exchanger and dissipates the heat into the medium of your heating system, air in case of ventilation systems, or water in case of heated systems with radiators and heated floors. After transferring the heat, the gas cools down and becomes liquid again, and then it returns to the outside unit to capture heat again. The process is continuous with pauses and adjustments in intensity depending on the final temperature difference from the first medium, the outside air, to the final one the heat pump needs to ensure. So if it's colder outside and you want a higher temperature inside, the heat pump would need to work more to compress the refrigerator to the hot gas state. But since the actual heat is captured by tricking with the refrigerator liquid and compressing it, the whole process consumes energy indirectly on compressors, fans and circuits, and not on directly heating the water as it would be with an electric kettle. And that is why it is much more efficient. Actually, it's 3 to 5 times more efficient. And here is where a crucial parameter comes from: COP, or coefficient of performance, which is basically a number that tells you how many kilowatt hours of heating energy a heat pump provides into a system by using 1 kilowatt hour of energy. That COP varies in real time depending on the temperature difference the heat pump needs to operate in, but in colder climates you can see averages from 3.0 to 4.0, and in milder climates you can see averages from 3.5 to 4.5 and sometimes to 5.0 and above. And COP also varies depending on how efficient are the compressors and circuits in your heat pump, which is why choosing a better one gives you extra efficiency. All in all, this is why heat pumps are considered an energy efficient solution, because by using an intelligent lever, they can provide up to 4 times more heating energy than they consume. And that means energy savings nationwide and globally. And that also means switching in the form of energy used for home heating, from natural gas or other hydrocarbon to be burned, to electricity, which is a universal form of energy and can be generated in a renewable zero CO2 way. And that is precisely why heat pumps are also environmentally friendly if the energy comes from renewable sources in your home grid, or maybe from your own home solar panels. Well, I'll get to my experience now of choosing a heat pump, and I have a curious case when I already had a gas boiler installed in the system. But I think this experience is even more precious to share, because there are many among us who already have a system in their home installed and think of adding the heat pump to it. And it also covers the case when you construct everything from zero. You see, I made a complete reconstruction of the house with the project sketched a few years ago when heat pumps were not such a preeminent trend yet, and I haven't got so close to study them. The house has been completely insulated with an entire new heating system installed, with new pipes, new heating floors on a part of the house, new radiators, and a new gas boiler. And then 2022 came, when prices skyrocketed here to about $1.6 per cubic meter, which equates to about 15 cents per kilowatt hour, or about $1.5 per every 10 kilowatt hour of natural gas. So it would mean an absurd bill for heating, with the risk of having shortages nationwide. I have decided I need an alternative, a much wiser one, with the goal of becoming energy independent in long term. And after studying it deeper, heat pump came to be the choice. So after having the new initial system installed with a gas boiler, in 2022 I added the heat pump into the circuit and have both solutions available to use now. In the next video I will show you the exact configuration we used to connect the heat pump into the existing heating system with a gas boiler, so it's a good reason to subscribe to Watt Energy channel and set your notification bell so you'll know when a new video arrives. But I can tell you the most important thing or number. In the complete season, heat pump proved to be so efficient for me that I've connected the gas boiler only twice, for a few hours. Not days, hours. And I have consumed only 6 cubic meters of natural gas for the entire season, which equates to about 63 kilowatt hours of gas. How to choose the right power for the heat pump? Well, I was consulted by a specialist when choosing the right one, and you should be too, because a specialist will have a look into the specifics of your house. Square footage, ceiling height, how insulated is it, what windows do you have, what temperature do you prefer to have inside, and of course the local climate you live in. The starting number, depending on where you live and what units are more common in your region, is to have 8.8 kilowatt per 1000 square feet or 9.5 kilowatt per 100 square meters. But that doesn't take into consideration many other factors, especially how insulated your home is. In my case, 270 square meters or 2900 square feet would need a power of 25 to 26 kilowatts. But I have a 40% less powerful heat pump thanks to several elements. A completely newly insulated house, which accounts for a lot in thermal efficiency. Low E4S insulated windows. Also, the first floor of the house, the semi-basement floor, has only 2.2 meters, which equates to 7.2 feet in height, while the other floors have 2.6 meters, which equates to 8.5 feet. Besides that, few people will tell you but having floor heating instead of radiators actually allows you to keep a lower temperature in your system to maintain the desired warmth, and the difference can be significant. Having an uninsulated home in a colder climate can require you to have 55 to 60 degrees Celsius in your heating system, and that can be above the temperatures heat pump is designed for. So having a heat pump in an old uninsulated home in a cold climate sometimes just doesn't work. A normally insulated home can require having 45 to 50 degrees Celsius for the water in your system. Having a well-insulated house would require 38 to 40 degrees only, and if you have floor heating, maybe even mixed with rooms with more section of radiators, can allow you to keep about 35 to 38 degrees in your system. And that makes a huge difference. If you know your home is well insulated, then you can opt for an 11 kilowatt heat pump instead of 16 kilowatt or 16 instead of 24. And your energy consumption will be much lower. So the basic rule would be to try to have your home insulated as good as possible, and if it's suitable for you, to incorporate floor heating at least in living room, kitchen, bathrooms and so on. What temperature settings did I use in winter? In my house we have floor heating for the large living room on the second floor, for a part of children's room with a larger panoramic window, and for all of the bathrooms. All the rooms and halls have radiators. Not the most efficient formula for a heat pump, especially that this Hitachi model allows to have either one or two circuits for the heating system. For example, one for floor heating and the other for radiators. I have only one circuit, and that makes my numbers easier to beat by you if you come up with a more efficient formula. And still I have managed to keep my heat pump temperature from 35 to 38 degrees Celsius most of the time. 39 to 40 degrees in the system were set only when we had -10 at night outside and -5 at most in the midday. 41 to 42 degrees in the system were set only a couple of times during this winter when we had -14 and below, which equals to almost 0 Fahrenheit. But that was maximum, and with that temperature in the heating system we had 21 degrees at the lower basement floor, 24-25 degrees on the second floor thanks to a larger floor heating area which emanates more heat, and 22-23 degrees in all of the bedrooms on the third floor. And that's a temperature that allows you to stay inside in a t-shirt only when it's minus outside. Normally I would set at least 2 degrees lower, but I set a warmer temperature this year because of a small child we have. So basically there is even more to improve in efficiency in your case comparing to my numbers. What climate do I live in? Well, it is what's called moderately continental. November, December and January were a bit colder this season, with an average of -3 Celsius or 26 Fahrenheit, and February and March were a bit warmer, with about +3 Celsius, which equates to 37 Fahrenheit. We had weeks of cold weather with 2 waves of constantly -10 and lower, and the lowest of the season being -17 Celsius, which equates to almost 0 Fahrenheit. But that was 2 times only, 2 nights. Has the heat pump worked in really cold conditions? Yes, always, even at -17 degrees Celsius or almost 0 Fahrenheit. The colder it is, the more energy it needs to compensate with compressors and heaters, so it's naturally that at -15 it consumes more energy than at +5. But it works, and Hitachi actually guarantees working at as low as minus 25 degrees Celsius or minus 13 degrees Fahrenheit. There were years in my region when we used to have maybe once or twice per winter such low temperature, but in the last 7 to 10 years we haven't any. What I have noticed in winter is that the outdoor unit can cover sometimes with frozen condensate, so you may begin to wonder if it can still work properly. But it can. It defrosts from time to time and it melts the ice condensation on the heat exchangers. And I have also noticed that when it's very cold outside and the outside unit is covered in thicker condensate, sometimes the temperature indicator on the inside the unit display shows a lower temperature than the actual one. For example, minus 20 instead of minus 11 or something like that. And the temperature value gets back to normal after defrosting. I guess that's due to the temperature sensor location in a place where it also covers with frozen condensate in really cold weather. That's something I've noticed, especially at below minus 10 Celsius, but it doesn't affect the heat provided inside. I guess it can affect a bit the efficiency by the heat pump algorithms by taking into consideration a lower temperature than the actual ones for that short period until defrosting. How easy is it to adjust temperatures and to operate it? Well, it is quite rare that you have to adjust anything on the heat pump, usually only when outside temperature changes by a lot and you don't have a thermostat to adjust it for you. But basically adjusting it is super easy. You can see the current state on the main screen, and with these arrows you can just navigate to heating system settings and domestic hot water settings. So when you are at the desired category, just press up and down the arrows to adjust temperature, and after a second it is confirmed. I have told you before the temperatures I used for the heating system, and for DHW I used 45 for a while, then put it down to 44 and it was okay. Tried 43 but it felt like insufficient for us, so 44 was the value which we came up to. When you are at the category, you can switch it on or off, so in summer you just switch the heating off and leave the domestic hot water on. In the cold season, when both are on, it actually heats only one of the systems at a time, not both simultaneously, and it alternates which system is switched to, doing that automatically to keep both to the desired temperature. Usually you can expect that it would use about 10% of the energy to keep the hot water in the boiler and about 85 to 90% for heating. And you can manually set a full program for an entire week on this Hitachi model for each day of the week by hours. For example, setting that on nights you want 2 degrees colder, in the morning when you wake up you want the temperature back to normal and hot water ready for you, and then during the work hours when nobody is home you can reduce the temperature to a decent minimum, and then 2 hours before you come back the heat pump will raise the temperature again for a comfortable evening. And on weekends you can choose to have warmer temperature during the day, for example. I haven't tried scheduling myself, so I cannot tell you from my own experience how much it actually saves in energy, but it should make a sizable difference in getting even more efficiency, maybe 15-20% or more. So there are additional ways to make it even more energy efficient. Is the heat pump loud? Well, this Hitachi inside unit is actually absolutely quiet. It is quieter than a fridge. You barely hear anything if you listen in silence, and the actual sound generated by this unit equals to maximum 39 decibels. The outdoor unit is a compressor, a double one here, so it can be louder in some cases. I specifically looked into the noise level when choosing this heat pump, and this model was like 3 to 10 decibels lower than the other comparable variants. This double unit actually has 67 decibels maximum. So now you mainly hear the air blow sometimes, but that's not something to bother you or your neighbors. And I must admit, I have thought of my neighbors when deciding for it. And a very important thing few people will tell you about: try not to place your outdoor unit directly on your house wall if possible, because it is a compressor that will go from 0 to its designed RPMs each time it restarts, and it will transmit vibrations into your house wall that you'll get to hear, especially at night. I have constructed this platform here, which is not the nicest thing now until I finalize everything around it, but it is separate from the house walls. In case you can't do it due to space limitations, you can put the compressor on the ground, close to the wall but not connected to it, or you can put it on the wall but use some special dampers that can be a solution helping you to minimize those small vibrations. But never install an outdoor unit of the heat pump directly on the wall without using dampers to help you absorb those vibrations. Why did I opt for Hitachi? I did consider Mitsubishi as an alternative and Hyundai. There were some other cheaper options from not really known manufacturers, which I have excluded from start. And there are other good manufacturers of heat pumps that just do not have a strong presence in my region with sales and service. So if I'm not mentioning a brand, it doesn't mean it's not good. Hyundai was initially attractive for me as a rational decision, but the more rational choices were up to 11 kilowatt of power, which were unsuitable for me. At 16 kilowatt, the energy consumption stated in comparison was higher for Hyundai and the COP was lower. Hyundai had about 3.7 to 3.8. At this size and power, this Hitachi model has 4.0 to 4.4 average COP, which is excellent and which makes the heat pump technology energy efficient. The base COP mentioned in the technical sheet is considered usually for 7 degrees Celsius outside and 35 degrees in the system, and in the case of this Hitachi model, the base COP is 4.57. At 11 kilowatt, that is a very good number. But of course, my average temperature was not 7 degrees Celsius or 44 Fahrenheit, but lower, which means my average actual COP was closer to 4.0, 4.2. Smaller Hitachi models have an even better COP, by the way. So if you need a similar Yutaki Combi S model at 11 kilowatts, for example, for 180 to 100 square meters, its COP is not 4.57 as in my case, but 5.0. The smallest Combi model at 4.3 kilowatts with a smaller compressor suitable more for an apartment or a smaller house has a COP of 5.25. And its actual energy consumption would be 3 to 4 times lower, of course, because you also have a smaller area to heat. And finally, in my choice for Hitachi, I also considered the experience of manufacturer, the heat pump technological advancement, availability of a good service in my region, and warranty. Hitachi is usually a more expensive choice compared to Hyundai or other good heat pumps. But I considered it worth a difference in price thanks to efficiency and expected reliability. However, I considered that Mitsubishi, which is also Japanese and was about 30% more expensive than Hitachi, was not justified as a value, and it was actually a bit outdated in terms of soft and digital functions, although they had very good compressors. How much did such a heat pump cost and what's their price range depending on the power you need? Last year, when I ordered it, it cost from about 12,500 euros, which equates to about $14,000. All the installation work, with all the pipes required, can amount to 1,500 to 2,000 euro or dollars if you take into account also the underground electrical power line that may be needed, as in my case. Generally speaking, you can find a good heat pump starting from 5 to 7,000 euros or dollars for smaller areas of your home and go all the way up to 15 or more for larger areas. You should also take in consideration that a lot of countries, states and cities have subsidizing programs for heat pumps. So in some cases, you can be helped with up to 7,000 euros or dollars to buy one. In my region, I haven't applied for one, and even after paying it in full, after one season, I still consider it an excellent investment. Another way of making your investment even wiser is if you combine it with your ventilation system in your house, and it's applicable usually when the house is built from scratch or reconstructed and you plan it from start. Because heat pump technology is actually an inverse process from the one you know from air conditioning units, and it actually can provide cold for you, so work as an air condition. And if you combine it with your ventilation system, that means you don't have to buy a lot of air conditioning for your home, and you can replace that investment with the investment in your heat pump and actually have the coolness you want in summer through the ventilation system from your heat pump as well. Have I repaired something in a complete heating season? Have I called the service at least once? No, not for the heat pump. However, I had to insist with my electricity provider to level up the voltage on all 3 power lines connected to my house. But all that experience, as well as energy consumption in kilowatt hours per day, per temperature, per month, cost calculations and comparison will be here in the next videos. You see, having the gas boiler installed in the very same house allowed me to have a direct comparison between energy consumptions and costs on gas and on heat pump. So those numbers will be very curious and informative, I promise. I actually want to dedicate a video only on numbers, kilowatt hours and costs, and another video on showing you the complete setup of the heating system with heat pump and gas boiler as a backup and the interchange between them. And since we are on a new channel here that we want to dedicate to energy and technology, please subscribe and help us grow. And if this video was useful and informative for you, please like it and leave a comment telling us your impression on what you have seen and asking your questions. Thank you for watching and see you soon with a continuation on the Hitachi heat pump experience.